started.
The following video will help you with rearranging formulas. Yes, this is the old switcheroo. We'll be extending our knowledge. Instead of moving just numbers and operation around, we're going to be working with a little bit more with variables. Let's take a look at some of the vocabulary. Let's see if you can take a look at the corresponding words and unscramble them in your thoughts. Well, I hope you had time to unscramble those words. And if you're thinking equations, that'd be correct. We're going to look at rearranging equations that have variables across the equal sign, commonly known as literal equations. That will help us with using the order of operations in reverse. Are you familiar with the term SADMEP? Hopefully you are, as we'll be using that in the process of isolating variables. Common operations that you should be familiar with are addition, which is the inverse of subtraction, multiplication, inverse of division. Some that you should have come across but may have not connected is the root. The root itself is the inverse of its corresponding power. In this case, square root is the inverse of square. Cube root, represented by 3, is the inverse of a cube. Hopefully you've seen a pattern here where you see the root itself with the letter M as its root is nothing more than the inverse of that corresponding power. And we'll be using that in our operations today. Why is this important? Because in real world, not all variables are known. Some have to be calculated. And we'll be using formulas to help. Let's take the Winter Olympics, for example. Bobsleigh, you may have not known, was one of the first sports when the Olympics started in 1924. But it didn't get a big change until the 1950s, where they reduced the total weight crew. And the maximum weight was a very key measurement to help teams with a good push-off. Those that combined both of those elements had an advantage throughout the course of the race. So in order to help the coach out with this push-off calculation, we're going to refer our information to some of their criteria. Well, number one, the weight of a 4-person crew depends on the sex. So for instance, 4 men can weigh no more than 1,389, whereas women, a little bit much less, is 717 pounds for bobsled. But they each have to get these critical measurements. They have 50 meters in order to reach a speed of 14 kilometers per hour. And the coach is going to try to help his team be very successful at reaching these measurements. So there's going to be 2 key formulas to help in that. One involves Newton's law of force, and the other is a distance formula with the rate and change that you should have come across in the lesson. Now, the coach so far has determined the force and acceleration for the push-off. So we're going to revert back to that Newton formula, force is equal to mass times acceleration. If you did not notice, there's an invisible multiplication sign that does not need to be displayed, but it does exist. So we're going to go ahead and put it in to help us with applying the inverse order of operations. And always, we're going to take the inverse order going from left to right and determine, because we need to isolate out the mass, we're going to see if there's any addition or subtraction needed. There is none. So we'll go straight to the middle there because we did see that multiplication, and we know the opposite of multiplication is division. So we're going to divide out our known, which in this case is acceleration. So that way we can give the coach the advantage of easily finding the mass needed to reach the proper force and acceleration for that desired distance. So the final answer here, when M is by itself, will be force over acceleration. We'll get to that mass. So the coach is going to make sure that they reach that mass without violating the weight restrictions in order to get the desired force per acceleration ratio. Once the crew is set, the coach will turn attention to the equipment. One of the key equipment is the pilot's helmet. Since the rest of the team members are behind the pilot, the drag force can be estimated for that frontal area formula to help the coach determine the proper fit for the pilot's helmet to reduce drag. So within this formula, we want to get the radius isolated. Again, we're going to go to that SADMEP, going from left to right to see if there's any addition or subtraction needed in order to isolate R. Again, in this example, there isn't any. So we can jump right back to that middle and do the inverse of multiplication to first get that pi away from the R squared, since the R is our desired variable this time. So we're going to divide both sides by pi. Once pi is isolated or taken away and canceled on the right-hand side, we can focus our attention onto the exponent according to SADMEP. Now the inverse, if you recall back in the discussion, of the power is its corresponding root. So here we want to take the square root of both sides. Once the square root is taken, on the right-hand side, that square and the root will cancel each other out, retaining only the R. Well, there is a special character that does need to be introduced here. Anytime you take the square root, we will need to ensure that we include the plus or minus due to the fact that the radius, in this case, will be positive, but in certain example, it can be negative. What about some other examples not pertaining to a bobsled? Well, in this case, we want to solve for the variable L. Each equation depends upon how we start based upon where L is located. And if you notice in these two examples, L is presented in two different forms. So again, we're going to work with that SADMEP, and we're going to remove all the other numbers and variables on the right-hand side away from the L. And we're moving across the equal sign, so we must use the inverse order of operations. So SADMEP tells us we're going to first look for any addition or subtraction, then move for division multiplication, and then our exponent parentheses. Well, in the left side, we do not have any addition or subtraction, so we can go directly to the multiplication or division. So I'm going to go ahead and divide both sides by 3. My apologies, we're going to multiply both sides by 3. But on the right-hand side, we need to go back to the beginning because S does need to be subtracted since it's actually added. And yes, we do not use this minus sign, we use the operation in front. There is no sign because there's an invisible plus sign, just like we have a visible 1 and a visible multiplication. They do not have to be shown, but they do exist. So for the right side, we're going to go ahead and subtract S to both sides. And here, the S's will cancel each other. Here, the 3's will cancel each other. There is still more to go, so we're going to move on. Clean up any gaps that may exist once items have already canceled out. And we're going to look for the next inverse operation that will assist us with getting L by itself. Going to the left side, we still have that 4 and the S in front of the L. So we do want to take care of those. You can do them separately, but since it's the same operation, we're going to take care of them all in one inverse step. So we're going to divide both sides by the 4S. On the right-hand side, we have both a negative and we have this E. Well, let's start with the activities on first getting rid of the E, and then we'll come back to the negative. Since the E is being divided by, since the L is being divided by the E, the inverse operation for that one will be multiplication. So this requires us to multiply both sides to the left by E in order to get our task of getting L by itself. On the right, the E's will cancel. On the left, the 4 S's will cancel. You've already met one task. You've already gotten the left-hand side with L by itself. But there's still more work to do on the right-hand side. L still has some things to get rid of. Now, if you notice, when we multiply both sides here, initially the parentheses were not there. So make sure that the parentheses are put in place to protect the fact that on the left of this equal sign, the E is going to be multiplied both the O and the S. And now we're going to focus our attention to getting rid of this minus sign in front of the L. This here is a -1. Although it's not showing the 1, remember it does not have to show. And it's actually multiplied by L. We want to do the inverse of that. And we know the inverse of multiplication is division. So we still need to go ahead and divide, again, I'm going to correct that, divide both sides by -1. This way we have one last step in the cleanup to ensure that the L is by itself on both equations. Now, clean up any spaces. So we're going to bring the L closer to the equal sign since the negative is no longer present. And although this -1 is in front here, in order to make it look more presentable, we're going to go ahead and take the 1 out, and we're just going to leave the negative. -1 or negative is the same thing. It just cleans up the equal sign. What I have is to have the extra number there. This video has gone through several examples to help you with rearranging formulas using the inverse order of operations. Definitely go back and replay any sections that you would like in order to go back through.